To utilize a 20 kilowatt generator with load shedding for a 300 amp service that feeds two 150 amp main breaker panels, several steps should be considered. Firstly, install an automatic transfer switch, often referred to as an ATS, with load shedding capabilities at the service entrance. It's crucial that this ATS is rated for at least 300 amps to handle the full service capacity. Consider using a Honeywell ATS. Honeywell offers models like the LV12 72,000, which is a 120 amp unit, or the LV24 72,000, which is a 240 amp unit specifically designed for load shedding application. These particular ATS units often come equipped with double lugs, facilitating easier connections and potential expansion in the future. Secondly, consider upgrading the main breaker. Replacing the existing 300 amp main breaker with a higher capacity breaker, such as a 400 amp or even a 500 amp breaker, might be necessary depending on the overall load and local electrical codes. Thirdly, you should install subpanels. Two 150 amp subpanels should be installed as subfeed panels directly from the automatic transfer switch. This configuration allows for better control and distribution of power during generator operation. Fourthly, configuring the load shedding function of the automatic transfer switch is very important. The automatic transfer switch should be configured to automatically shed non-essential loads in situations where the generator's capacity is being exceeded. Typically, the automatic transfer switch will continuously monitor the generator's output and, based on predefined priority levels, shed certain loads to prevent overloading the generator. Fifthly, establish the generator connection. Connect the generator to the automatic transfer switch through either a manual or an automatic interlock. This is a critical safety measure to prevent backfeeding power onto the utility grid, which can be extremely dangerous for line workers and can also damage equipment. Please keep in mind that the specific details of the load shedding configuration and the actual wiring will significantly depend on the specific model of the automatic transfer switch being used, as well as the types of subpanels chosen. It's essential to consult with a qualified and licensed electrician to ensure that the installation and wiring are performed correctly and safely, adhering to all applicable electrical codes and regulations. Keep in mind the selection of an appropriate automatic transfer switch, or ATS, is paramount for integrating a generator into an electrical system, especially when load shedding is required. An automatic transfer switch not only facilitates the seamless transition between utility power and generator power, but it also plays a critical role in managing the electrical load to prevent overloading the generator. Several factors should be considered when selecting the appropriate automatic transfer switch, including the amperage rating, voltage requirements, load shedding capabilities, and compatibility with the existing electrical system. The amperage rating of the automatic transfer switch should match or exceed the service amperage of the electrical panel it is connected to. In the case of a 300 amp service, the automatic transfer switch should be rated for at least 300 amps to handle the full electrical load. It is also important to verify that the voltage rating of the automatic transfer switch is compatible with the voltage of the electrical system. Automatic transfer switches are available in various voltage configurations, such as 120/240 volts for residential applications and 208/120 volts or 480/277 volts for commercial and industrial applications. Load shedding is a critical feature for generator systems, especially when the generator's capacity is less than the total electrical load of the building. Load shedding involves selectively disconnecting non-essential loads during generator operation to prevent overloading the generator. Automatic transfer switches with load shedding capabilities can be programmed to shed specific circuits based on predefined priority levels. For example, non-essential loads such as electric heaters, air conditioners, and pool pumps can be shed to ensure that essential loads such as lighting, refrigerators, and medical equipment remain powered during a power outage. Compatibility with the existing electrical system is another important consideration when selecting an automatic transfer switch. The automatic transfer switch should be compatible with the type of electrical panel, wiring configuration, and grounding system used in a building. It is also important to ensure that the automatic transfer switch complies with all applicable electrical codes and standards. The National Electrical Code, or NEC, provides detailed requirements for the installation and operation of automatic transfer switches and generator systems. The installation of an automatic transfer switch and generator system should only be performed by a qualified and licensed electrician. A qualified electrician will have the knowledge and experience to properly size the automatic transfer switch, install the wiring and connections, and configure the load shedding settings. The electrician will also ensure that the installation complies with all applicable electrical codes and standards. In addition to selecting and installing the appropriate automatic transfer switch, it is also important to properly size the generator to meet the electrical needs of the building. The generator should be sized to handle the essential loads that need to be powered during a power outage. A load calculation should be performed to determine the total electrical load of the essential circuits. The load calculation should take into account the wattage of all the lights, appliances, and equipment that will be powered by the generator. The generator should be sized to provide enough power to handle the peak load of the essential circuits. It is also important to consider the starting wattage of motors and other inductive loads, as these can draw significantly more power when starting up. The generator should have enough capacity to handle the starting wattage of these loads without overloading. Regular maintenance is essential for ensuring the reliable operation of the automatic transfer switch and generator system. The automatic transfer switch should be inspected and tested regularly to ensure that it is functioning properly. The generator should also be serviced regularly, including oil changes, filter replacements, and spark plug replacement. A maintenance schedule should be established and followed to ensure that the automatic transfer switch and generator system are always in good working order. Load shedding is a technique used in electrical systems to reduce the demand on a power source, typically a generator or an uninterruptible power supply, during periods of high load or when the power source has limited capacity. It involves selectively disconnecting non-essential electrical loads to prevent overloading the power source and ensure that critical loads continue to receive power. The primary purpose of load shedding is to maintain the stability and reliability of the electrical system by preventing the power source from being overloaded. When a generator or an uninterruptible power supply is overloaded, it can lead to voltage drops, frequency fluctuations, and even complete system failure. Load shedding helps to avoid these problems by reducing the overall demand on the power source. Load shedding is particularly useful in situations where the available power is limited, such as during a power outage when a generator is being used as a backup power source. In these cases, it is important to prioritize the electrical loads and ensure that essential loads such as lighting, refrigerators, and medical equipment continue to receive power. Load shedding can be implemented manually or automatically. Manual load shedding involves manually disconnecting non-essential loads by turning off circuit breakers or switches. This approach is typically used in smaller systems where the load is relatively easy to manage. Automatic load shedding involves using a control system to automatically disconnect non-essential loads based on predefined priority levels. This approach is typically used in larger systems where the load is more complex and requires more sophisticated control. Automatic load shedding systems typically use a combination of sensors, controllers, and switches to monitor the electrical load and disconnect non-essential loads as needed. The sensors measure parameters such as voltage, current, and frequency, and the controllers use this information to determine when to shed loads. The switches are used to disconnect the non-essential loads from the power source. There are several different types of load shedding strategies that can be used depending on the specific application and the characteristics of the electrical system. Some common load shedding strategies include, firstly, priority-based load shedding. This strategy involves assigning priority levels to different electrical loads and disconnecting loads with lower priority levels first. This ensures that essential loads with higher priority levels continue to receive power. Secondly, frequency-based load shedding. This strategy involves monitoring the frequency of the electrical system and disconnecting loads when the frequency drops below a certain threshold. This helps to prevent the power source from being overloaded and maintains the stability of the system. Thirdly, voltage-based load shedding. This strategy involves monitoring the voltage of the electrical system and disconnecting loads when the voltage drops below a certain threshold. This helps to prevent voltage drops and ensures that all loads receive adequate voltage. Fourthly, time-based load shedding. This strategy involves disconnecting loads at predetermined times or intervals. This can be useful for managing loads that are only needed during certain periods of the day or week. Load shedding can be implemented using a variety of different technologies and equipment. Some common components used in load shedding systems include firstly, automatic transfer switches. Automatic transfer switches are used to automatically switch between the utility power source and the generator power source. They can also be used to disconnect non-essential loads during generator operation. Secondly, programmable logic controllers. Programmable logic controllers are used to control the load shedding system and make decisions about which loads to disconnect. They can be programmed to implement different load shedding strategies and can be integrated with sensors and other equipment. Thirdly, circuit breakers and switches. Circuit breakers and switches are used to disconnect non-essential loads from the power source. They can be operated manually or automatically by the control system. Fourthly, sensors. Sensors are used to monitor the electrical load and provide information to the control system. They can measure parameters such as voltage, current, and frequency. Load shedding is an important technique for managing electrical loads and ensuring the reliability of electrical systems. It can be used in a variety of different applications, including backup power systems, uninterruptible power supplies, and industrial facilities. By selectively disconnecting non-essential loads, load shedding helps to prevent overloading the power source and ensures that critical loads continue to receive power. When dealing with a 20 kilowatt generator to back up a 300 amp service, understanding the generator's capabilities and limitations is paramount. A 20 kilowatt generator, when operating at 240 volts, can typically provide around 83 amps of continuous power. This is derived from the formula power equals voltage times current, so current equals power divided by voltage. Therefore, 20,000 watts divided by 240 volts equals approximately 83.33 amps. Given that the service is rated for 300 amps, it is clear that the generator cannot support the entire load simultaneously. This is where load shedding becomes essential. Load shedding involves selectively disconnecting non-essential circuits or appliances to ensure that the generator is not overloaded and can continue to power critical loads. To implement load shedding effectively, it is important to identify and prioritize the various electrical loads in the building. Essential loads, such as lighting, refrigerators, medical equipment, and critical communications systems, should be given the highest priority. Non-essential loads, such as electric heaters, air conditioners, pool pumps, and non-critical appliances, can be assigned lower priority levels and shed when necessary. The automatic transfer switch with load shedding capabilities should be configured to monitor the generator's output and automatically disconnect non-essential loads when the generator's capacity is being approached. This can be done by setting thresholds for generator output, voltage, or frequency. When these thresholds are reached, the automatic transfer switch will disconnect the lower priority loads to prevent overloading the generator. The specific wiring and configuration of the load shedding system will depend on the model of automatic transfer switch and the types of loads being shed. It is important to consult with a qualified electrician to ensure that the system is properly installed and configured. The electrician can also provide guidance on how to prioritize the electrical loads and set the appropriate thresholds for load shedding. In addition to load shedding, it is also important to consider other factors such as the generator's fuel supply and maintenance requirements. The generator should have an adequate fuel supply to run for an extended period of time, and it should be regularly maintained to ensure reliable operation. Regular maintenance should include oil changes, filter replacements, spark plug replacements, and inspections of the generator's electrical and mechanical components. The installation of a generator and automatic transfer switch should always be performed by a qualified and licensed electrician. The electrician will ensure that the installation complies with all applicable electrical codes and standards and that the system is safe and reliable. The National Electrical Code, or NEC, provides detailed requirements for the installation of generators and automatic transfer switches. Some key NEC requirements include proper grounding, overcurrent protection, and wiring methods. The electrician will be familiar with these requirements and will ensure that the installation meets all applicable codes. When installing subpanels, it is important to follow all applicable electrical codes and standards. Subpanels should be properly sized to handle the electrical load they will be serving, and they should be protected by overcurrent devices such as circuit breakers or fuses. The wiring between the automatic transfer switch and the subpanel should be properly sized and installed, and it should be protected from physical damage. The subpanel should be properly grounded to ensure electrical safety. Grounding helps to protect against electrical shock and also provides a path for fault current to flow back to the source, which helps to trip overcurrent devices and clear faults quickly. The size of the grounding conductor should be based on the size of the service entrance conductors, as specified in the NEC. The grounding conductor should be connected to a grounding electrode system, which typically consists of ground rods, ground plates, or underground metallic water pipes. The grounding electrode system should be properly installed and maintained to ensure effective grounding. Proper bonding is also important for electrical safety. Bonding involves connecting all metallic parts of the electrical system together to create a low impedance path for fault current to flow. This helps to prevent voltage differences between different metallic parts, which can create a shock hazard. Bonding should be performed in accordance with the NEC. All metallic enclosures, raceways, and equipment should be bonded together using bonding jumpers or other approved methods. The bonding jumpers should be properly sized and installed to ensure effective bonding. Overcurrent protection is another important aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can cause overheating and fires. Overcurrent protection devices should be properly sized to protect the electrical circuits they are serving. The size of the overcurrent protection device should be based on the ampacity of the conductors in the circuit. The ampacity of a conductor is the maximum amount of current that the conductor can safely carry without overheating. Conductor ampacities are specified in the NEC. The overcurrent protection devices should be installed in readily accessible locations and should be clearly labeled to indicate the circuits they protect. Regular inspections and testing of the electrical system are important for maintaining electrical safety. The electrical system should be inspected regularly for any signs of damage, wear, or deterioration. Any problems that are found should be corrected promptly. The electrical system should also be tested periodically to ensure that it is functioning properly. Testing should include insulation resistance testing, ground impedance testing, and overcurrent protection testing. The results of the testing should be documented and kept on file. In addition to the technical aspects of installing and maintaining a generator and automatic transfer switch, it is also important to consider the permitting and inspection requirements of the local jurisdiction. Most jurisdictions require permits for electrical work, including the installation of generators and automatic transfer switches. The permit process typically involves submitting plans and specifications to the local building department for review. The building department will review the plans to ensure that they comply with all applicable codes and standards. Once the plans are approved, a permit will be issued. After the electrical work is completed, it will be inspected by a local electrical inspector. The inspector will verify that the work was performed in accordance with the approved plans and that it complies with all applicable codes and standards. If the inspection is successful, the inspector will sign off on the permit. It is important to obtain all necessary permits and inspections before operating the generator. Operating a generator without the proper permits and inspections can result in fines or other penalties. In summary, using a 20 kilowatt generator with load shedding for a 300 amp service requires careful planning and execution. The automatic transfer switch should be properly sized and configured to shed non-essential loads when the generator's capacity is being approached. The electrical system should be properly grounded and bonded to ensure electrical safety. Overcurrent protection devices should be properly sized to protect the electrical circuits. Regular inspections and testing of the electrical system are important for maintaining electrical safety. All necessary permits and inspections should be obtained before operating the generator. Consult with a qualified and licensed electrician to ensure that the installation is performed correctly and safely.